As you look at this figure, we've got a bunch of words up here, which basically just describe the shape. If you want, you can read that over, but I'm not going to say anything because it's all captured in this image. What I am going to say, though, are these interesting things down here. BD bisects ABE, that angle. So let's talk about what that means. BD is this line right here, and to bisect an angle, this angle right here, means you cut it into two equal halves. Okay, so that means this guy is the same exact angle as that guy right there. And we also have another bisector here. BE bisects angle CBD. CBD is, there it is. Okay, so that means this angle is equal to this angle right here. Okay, now, we now know a bunch of things about these equal angles. Unfortunately, there's nothing else given to me in this version of the problem. See these two lines right here? You might be tempted to think those are parallel lines, but in this problem I'm looking at, it doesn't say anything about it, so we cannot assume they are parallel. We just have to say, well, maybe they are, maybe they aren't. Which of the following statements must be true? Remember, all I know is that the green angles are all equal to the red angles. Well, one of the statements says ABD, DBE, and CBE. Okay, so one of the statements is basically me just saying that. All the angles, the red and greens, are equal to each other. And what's another thing here? DBE is equal to BED. Now we're getting into some interesting stuff. So if those angles are all equal, and remember they form a 180-degree arc total, because it's a straight line. So if they're all equal and they form a 180-degree arc, that means they're all equal to 60 degrees. So that's kind of interesting. But I think that's where we kind of have to stop, because I don't know what this DE line is doing. I mean, let's exaggerate this to just show the problem. For all I know, it looks like this. And we've got a small angle right there and a big angle right here. I can't say anything about these other angles. For all I know, they are actually parallel lines, and it just didn't say it. So perhaps they are equal, right? Maybe they're equal to each other. Or maybe the line cuts more like this, and we have a big one over here and a teeny one over here. We just don't know. So I think that's as much as I can say about congruent angles. Let's see if there was anything else in here. DBE, BED. Yeah, see, I cannot say that this, that's an eraser. I cannot say that this angle right here has anything to do with this angle. Just don't know enough. If those were parallel lines, then that would be different. ABD congruent to BDE, ABD. And I also can't say, here's something else I don't know, there's a lot. I can't say these two angles are equal, because I don't know if those are parallel lines. So for this problem that I'm looking at, all I've got is 1. That's the only statement I know for sure. Now let's just talk about what would happen if those were parallel lines. I want to hit that point. If these were parallel lines, there's interesting things that happen now, which is the following. When you have parallel lines and you have a transversal, like this thing right here, it means angles across that line are equal to each other. So look what I get. That red angle right there. This red angle is equal to this red angle because they're transversals across parallel lines. So, back it up. What else can I say? Well, I know that this angle right here is equal to this angle right here because, again, transversals in a parallel line. And I know that green angles are equal to red angles. So that tells me, hey, we've got 60-degree angles all over the place here. I'm looking at an isosceles triangle. Those are the sorts of things you can start to say once you know the lines are parallel. But absent information about whether the lines are parallel or not, there's not a whole lot you can say here.